A port channel is basically taking individual connections and combining them so that they are utilized and seen as one connection. So between an iOS switch and another iOS switch, if you want to have multiple connections for either redundancy, right? You could have a failed patch cable, you could have a failed SFP, a failed port, and to prevent a single point of failure, you can create two connections in between them to give you that redundancy. So it could be that you maybe even just need the bandwidth. You need more bandwidth for traffic that's going through it. So typically you'll see where if you have a connection between two devices, that 9 times out of 10, you will do it as a port channel to provide redundancy and to give you more bandwidth. That's the purpose of the port channel. Going in between two iOS switches, you can create a port channel on one side and you'll create a port channel on the other. This is kind of a design thing and then also preference thing. When you're doing it with iOS, where you specifically are manually setting the port channel, it is best practices if you set this one to port channel 3, that the corresponding switch that you're going to be connecting it to, that you create port channel 3 on it for that connection. Does it have to be? No. It sees it individually, so it's just combining it and doing everything internally and sending the traffic. That port channel information is not traversing across those connections. You can have port channel 3 over here and port channel 21 over there, and it will work normally. But for best practices, for continuity to be able to read configs, be able to decipher and put things together, it's best to have them set as the same, typically. But we'll get into why in the ACI that doesn't matter. But for regular iOS to iOS, that's best practices. So now if you create a port channel, the next thing that I've seen that people are misunderstanding is whenever they're creating their port channels and adding their configuration onto the interfaces, that they're going into the interfaces and adding the config, which is not correct. The first order of operation is to go into each interface that you're going to include in a port channel and add it to the port channel. And that is all you will do. You'll log into that interface, channel group, whatever mode, on, active, whatever it needs to be, and then go into any other interfaces that you are going to be adding to that same port channel and do that same thing. If you're doing it on gig 1 and gig 2, you'll log into gig 1, channel group 3, mode active, then go into gig 2, channel group, mode active, put them in the same channel group. Then once you do that, on the iOS devices, it will create that port channel if it's not already created. Then you log into the port channel itself, interface port channel 3, and you add the commands. When you add the commands in port channel, it pushes the config of that port channel to the interfaces. I've seen where problems happen if you try to make changes on the interface with configuration that's part of the port channel on an individual interface. It causes various issues, especially if you get them out of sync to where you make a change on one interface and then you go into and don't make the change on the other interface. Now you got two interfaces part of the port channel that aren't exactly the same. It's best practices to always make those changes on the port channel interface itself. There is exception to where you'll do it on the interface, and there's certain commands that you do on the interface because it's related to that interface. The speed, duplex, that is port specific, not a port channel specific. So those kind of commands would be the exception to that. That's how you would create the port channel and add the config. Then they will start talking back and forth across it. Let's say you decide later to go back and you want to add a third connection to here. That's an easy addition that will not affect the traffic here. So you'll go into gig 3, channel group 3, mode active. It has to be exactly the same as what the others are. Then you go back into the port channel interface and you just copy your config and repaste it, your port channel information. So you're just duplicating what's ever in the port channel and it'll push it down to that other interface. And you'll do that on the other side with that connection. And whenever you turn no shut, it'll add it to that port channel. And then you will have 3 connections in there and it'll just start load balancing the traffic. One thing to think about with this port channeling is if you don't do a port channel and you connect 2 individual connections to this iOS switch and their individual trunks, what would you expect to happen? Creating a loop, right? Because you've got 2 individual connections, it's going to send information across and it's going to be able to get back. And so now you're creating this loop. And so spanning tree should come in here and shut one of them off is the way it should work. But now, since you've done that, now you only have a redundant connection. You don't have a truly active connection. So that's before port channels and all that. That's how they would do redundant connections. They would have 2 connections. One of them would be spanning tree would cut it off and the other one would be active. If this one went down, then topology changed. Spanning tree would go out, look, it would see that this connection was there and it would bring it up and then bring it back up. But during that time while spanning tree is doing its little calculations, that connection is severed. That's usually not the best way to do and to rely on spanning tree for that, because you'll have, depending on how big a topology you've got and all the different configurations that you've got on spanning tree, a 30-second outage on a network, especially whenever you're sitting there watching it, seems like an eternity. Port channels are your better option for that. Now let's talk about having another switch, totally separate switch. These are not connected. This is totally one switch. This is a totally another switch, not in the same stack or anything. And you have a connection from it coming into it. We want to add another connection to it after the fact, to add another connection to it for redundancy or to provide more bandwidth. So between the 2 switches, you're going to have to create a port channel unless you're going to let spanning tree handle it, but that's not the best way. So we want to create a port channel. So the only way to add the existing connection into a port channel is you have to completely bring it down. So this would be fully interruption of service during this changeover. So you'd have to create a port channel on the top switch and create a port channel on the bottom switch, adding those interfaces in that need to be in there, and then no shutting those interfaces to bring them up. But that would be a full disruption of service to add a port that is just a standard trunk port into a port channel to be able to add multiple connections in. You can do prep work ahead of time to make it so that the downtime is not as long, I guess. You know, typically what I'll do is I'll have all my configurations sitting there and in the order it needs to be. Interface, whatever interface, channel group, interface, whatever channel group, port channel, interface with the commands that I've got and ready to go. And so once I get ready to do it, my first command would be to default that existing connection and then run my script to add both of those into that port channel and then push the port channel information in there. And then once that port channel information is pushed to it, that existing connection should come up and then you can no shut that other one that you added. Okay, so this is where we get into where we're doing a port channel now into the ACI fabric. Whenever we look at the leaves on the ACI, here's example just 201, 202, they're in a pair. They're not individual switches, they are paired together and share the same domain, broadcast domain and configurations. Like the Nexus, whenever you make a configuration on one switch, you then have to log in and make configuration on the other switch as well to keep them in sync. One thing that you need to be mindful of, if you create a vPC virtual port channel on one switch in the pair, you must create it on the other switch in the pair. You cannot create a vPC on only one of them. If you do, you will generate errors and issues. This is basically the same thing. So we're going to create a link port channel. Typically, what we're going to want to do with the iOS switch is we want to, for the maximum redundancy, we don't want to go to the same switch in the cluster. This is where we get our redundancy. So we have one iOS switch, but then we're getting redundancy with having two connections, but then we're getting further redundancy by going into two separate switches. If you did this in our first example and you went from one iOS switch to two separate iOS switches and you tried to port channel them, then you would get failures because it's not seeing those connections. On iOS, you have to go from one iOS device to the other iOS device. You know, granted, if it's like a stacked switch situation, they're seeing it all as one. So you could go into different ports on or different switches within a stack, but you couldn't go to a totally different switch typically. I say typically because there are some things that allow you to do that, which is VSS, virtual stack switch. So that's a protocol that allows two switches to be kind of seen the same, kind of like how Nexus and ACI work, just at a different protocol with different things. But I'm not going to get into that right now. But typically it's one device to the other, to where whenever you deal with Nexus and iOS, the switches are seen as individuals because you have to make configurations individually on those switches, but there is a link in between them that is passing information so that they can be configured and seen as one and allow those virtual port channels. That's why they're virtual, because they're not a true port channel because they're crossing across two separate switches. The link between them is what sends that information for it to have a port channel from one iOS device come in and see it as one. This is your typical configuration that you would want to do. And like I said, if you create a vPC on this one, you have to create a vPC on that one. If you do this and you create a vPC on this one and you don't create a vPC on this one, you're going to have major issues. If you absolutely had to do this, there is a way to do it in ACI, but you're just changing it to a standard port channel. You're not doing it as a vPC. vPCs is what crosses over here. Just a port channel does not. But that is not the design that should be used. Design implement is the connection going into each leaf whenever you're doing that, and then creating a vPC between them that those two ports will utilize. Now, we do have situations to where we've got this iOS switch and it needs more bandwidth. And so just like in the other example, we will add another connection down. And when we add that, we'll add another connection up here. So they'll be in pairs. But then when you do this, those need to be, all four of these need to be in the same port channel if you're coming back to the same iOS. So all four of those connections now need to be in the same vPC. And it wouldn't be a separate one, because if you do create port channel and then these outside ones in a port channel, it's basically doing the same thing as if you went two connections into the same switch. You would create that loop. So on the iOS device, you would have one port channel, and on the ACI, you would create one vPC that would be across those leaves.